At 54 qubits, they opened a molecule, and they could measure it here, observing it in like Silicon Valley or wherever this is. And then they opened the same one. It appeared in London, and they verified that the changes they made in Silicon Valley were happening with it's the same molecule, and it was happening at the same time someplace else.
What?
Quantum computers is a hardware question where it actually increases your ability to do much more than with an ordinary digital computer.
Sam Altman warns a breakthrough quantum computer experiment.
At 54 qubits, scientists opened a molecule and began to measure it. This groundbreaking experiment took place in a location reminiscent of Silicon Valley, a hub of technological innovation. They observed the same molecule in London, confirming that the changes made in Silicon Valley were indeed occurring simultaneously in another part of the world. This remarkable synchronization has led to a recent quantum computer experiment that may provide the first real evidence of a parallel universe shifter. The discovery has left scientists in a state of stunned amazement, and if it holds true, it could revolutionize our entire understanding of reality. For decades, physicists have speculated about the existence of parallel universes, hidden realities that branch off from our own, governed by the strange rules of quantum mechanics. Until now, this idea has remained largely theoretical. But recent findings suggest that this may no longer be the case. A new quantum experiment has recorded something never seen before, an anomaly so bizarre that some researchers believe it could be the first tangible sign of information crossing between dimensions. Could this be the breakthrough that finally proves the existence of parallel universes? What does this mean for science, for reality itself, and even for the way we experience time? Before diving into the specifics of this discovery, it's essential to understand why quantum computing might be the key to unlocking the mysteries of parallel universes. Quantum mechanics has long hinted at the possibility of these alternate realities, and quantum computing could be the tool that finally uncovers the truth. At the heart of this idea is the many worlds interpretation, a mind-bending theory suggesting that every quantum event creates multiple realities. According to this view, every time a particle is measured, the universe splits, creating countless alternate timelines where every possible outcome happens simultaneously. This means that, right now, there could be versions of you living out completely different lives in realities that are just out of reach. While this concept may sound like science fiction, it emerges directly from the mathematics of quantum mechanics. Recently, a quantum computing experiment has delivered a strange result that could be the first real clue that these parallel worlds are more than just theoretical speculation. To understand why this experiment is so important, we need to look at three key phenomena in quantum mechanics: superposition, quantum tunneling, and entanglement. Superposition is the idea that particles don't exist in just one place or state, but in multiple states at once until they are measured. This principle is the foundation of quantum computing, where quantum bits, or qubits, can be both 0 and 1 at the same time, allowing them to perform incredibly complex calculations. Then there's quantum tunneling, a bizarre effect where particles can pass through barriers as if they temporarily vanish and reappear elsewhere. This suggests that reality isn't as solid as it seems. Perhaps the most fascinating phenomenon is entanglement, in which two particles become instantaneously connected no matter how far apart they are. A change in one particle immediately affects the other, even if they are light years away. This phenomenon is something that Einstein famously referred to as spooky action at a distance. The experiment in question focused on a strange anomaly that might be linked to something entirely new, a possible parallel universe shifter. Quantum computers, with their ability to process vast amounts of quantum interactions, have given scientists an unprecedented window into the deepest layers of reality. In this experiment, researchers were running standard quantum gate interactions when they noticed something completely unexpected. Instead of behaving as predicted, certain quantum states appeared to fluctuate in a way that couldn't be explained by known physics. Some scientists believe this could be evidence of quantum interference from another universe, where information might be subtly leaking between dimensions. If true, this discovery could change everything. The idea that quantum particles may be influenced by realities beyond our own would mean that the fabric of existence is far more complex than we ever imagined. Could it be possible that we are already experiencing tiny shifts between alternate versions of our world without even realizing it? Some researchers have speculated that unexplained phenomena, such as the Mandela effect, the widespread belief that collective memories sometimes differ from historical records, might be linked to subtle quantum fluctuations between dimensions. But what happens next in this discovery is even more shocking. The anomaly scientists detected wasn't just a random glitch, it followed a pattern. This pattern could hold the key to proving that parallel universes are not just possible but may be directly interacting with our own. The recent quantum computing experiment that stunned scientists wasn't just an isolated glitch. It was a pattern that defied explanation within known physics. Researchers at CERN and Google's Quantum AI Lab were conducting routine quantum experiments, testing quantum gate interactions to refine computations. In the middle of their tests, something completely unexpected happened. The quantum computer registered an anomaly, a fluctuation in the quantum states that wasn't supposed to be there. Initially, they assumed it was an error, a hardware malfunction, or even interference from external noise. However, after running multiple tests and isolating every possible variable, they realized that this anomaly wasn't random. It followed a distinct pattern, suggesting something far stranger than a mere computational error. The anomaly behaved as if information was appearing from an unknown source, seemingly emerging out of nowhere. This wasn't like normal quantum noise or expected computational fluctuations. Something else was interacting with the system. Some researchers believe this could be the first evidence of quantum interference from another universe. According to certain interpretations of quantum mechanics, if parallel realities exist, there might be moments when they briefly interact, creating small but detectable disturbances. If this anomaly is what some suspect a parallel universe shifter, then it means quantum computers have, for the first time, recorded possible evidence of information crossing between dimensions. While skeptics argue that this could be an undiscovered quirk of quantum mechanics, others suggest that this experiment could be revolutionary. If a quantum system is detecting and reacting to information beyond its own computational limits, it raises the possibility that alternate realities are not just theoretical but may be physically accessible under certain conditions. Some theorists speculate that this could mean parallel universes do not exist separately and unreachable, but instead exist in a kind of quantum superposition, occasionally overlapping with our reality. If so, what scientists have just detected might not be an accident. It could be a fundamental aspect of the universe itself, a hidden layer of reality we've never been able to measure before. The implications of this discovery are enormous. If quantum computers can detect anomalies like this, could they eventually be used to map interactions between parallel worlds? Could they help us understand whether information, energy, or even matter can travel between these realities? And if so, could we one day find a way to control or manipulate this process? These questions may seem like science fiction, but they are now being seriously considered by physicists trying to make sense of what this anomaly means. Here's where it gets even crazier. Long before this experiment, some of the world's most respected physicists had already predicted that something exactly like this could happen. One of them is Brian Cox, a leading expert in quantum mechanics who has long suggested that if parallel universes exist, quantum computers might be the first tools capable of detecting them. Now, with this latest discovery, his predictions may be closer to reality than ever before. Cox has been one of the most vocal proponents of the idea that quantum mechanics could reveal the existence of parallel universes. As a leading theoretical physicist, his work has explored the deep connections between quantum physics and the nature of reality, often challenging the way we understand existence itself. Long before this latest quantum computing experiment, Cox had speculated that if alternate realities were real, we might one day detect them through quantum interactions. His argument was simple yet profound: if quantum mechanics is correct, then parallel universes are not just possible, they may be necessary. Cox's reasoning is rooted in the many worlds interpretation, which suggests that every quantum event causes the universe to split into multiple versions, each playing out a different possible outcome. According to this view, we don't experience these alternate realities directly because our consciousness follows only one path through the countless branches of the multiverse. However, what makes this moment different is the emergence of actual data, an anomaly that could represent the first tangible sign of something beyond our current understanding. If Cox's predictions are correct, then this could be just the beginning. Future quantum experiments may reveal even more anomalies, perhaps even patterns that could help us determine whether parallel universes truly exist. If information is leaking between dimensions, it raises the question: could we one day find a way to control this process? These questions are no longer confined to the realm of science fiction. They are now being actively considered by physicists pushing the boundaries of quantum research.